welcome all of you. Good evening. आप सबका स्वागत इस सेशन के लिए. So students are requesting me to speak in Hindi also, but I am not that good in Hindi. Kindly adjust with me. I will try my level best. Here and then I will try to speak in Hindi, but my Hindi is horrible. So you will make fun of me. But okay, anyway, it is the content. So we have been discussing about water quality, water testing. So we started with the physical water quality. Physical water quality is defined by 4 parameters. One is temperature, color, turbidity, and odor and taste. So among this, temperature, color is completed. So we are in the middle of turbidity, right? So turbidity is the measure of opaqueness. So when light is not penetrating through media, so no object is visible. That resistance to light is normally offered by particle presence in water. So those particles resist light. So more particles present, water appear more turbid. Less particles present, water appear less turbid. So turbidity is straight away proportional to size of the particles. Inversely proportional to size of the particles. Particles are smaller in size, they produce more turbidity. Particles are larger in size, they produce less turbidity. Particles are smaller in size, they possess more surface area. Particles larger in size, they produce less surface area. So surface area matters ultimately. Okay? So turbidity is measured by devices. So many number of devices are available. One is Jackson turbidimeter. Then Bailey's meter. And nephrometer. So many are there in between also, but among them, nephrometer is the most popular to measure turbidity. Jackson turbidimeter and Bailey's meter, they work on the principle of light absorption. They measure light absorption. Based on that, they measure turbidity in water, whereas nephrometer measure turbidity by measuring light scattering. It works on the principle of light scattering. Okay? Some amount of light scattered 90 degrees to the light path, perpendicular to the light path. So it measure turbidity by measuring amount of light scattered 90 degrees to the light path or perpendicular to the light path. So nephrometer always measure turbidity in terms of NTU. Measure turbidity in terms of NTU, whereas these two measure turbidity in terms of JTU. So students are asking me quickly revise the content. So I'll try to do that. It is measured in terms of NTU, nephrometric turbidity unit. NTU stands for nephrometric turbidity unit. Okay? It measure turbidity by measuring the light scattered. So 90 degrees to the light path. Okay? That point also you have to remember. Sometimes in competitive exam, that principle also they are asking. And coming to drinking water standard with respect to turbidity. It should be anywhere between 5 to 10 turbidity units. Either it could be JTU or NTU, no matter, or plain milligram per liter or ppm also, it is okay. So it is expressed in terms of turbidity units. 5 to 10, it should not be at any cost more than 10. Less than 5 also okay, there is no lower limit, there is only upper limit. Permissible limit is different, tolerable limit. Permissible limit is 5, you can tolerate up to 10, so above 10 it is not allowed. So this is about turbidity. Next, odor and taste. Odor means smell. So odor is measured by a device known as osmoscope. Water thought to be odorless and tasteless. Therefore, any smell in water is objectionable. Odor is measured by device known as osmoscope. Osmoscope is inhaler kind of thing. Osmoscope, and it is expressed in terms of expressed in terms of threshold odor number. So here there is a chance for one numerical threshold odor number. So wherever there is a scope and chance for numerical is there you need to focus more in GATE exam. As we all know that GATE is more numerical oriented. So threshold odor number. TON stands for threshold odor number. So what is this threshold odor number? Threshold odor number is nothing but it is a dilution ratio at which odor is just detectable. So it is a dilution ratio at which odor is just detectable. So normally this threshold odor number is equal to A plus B by A. One equation is there. With the help of this equation we can work out threshold odor number. So area is equal to volume of water sample tested. It is an inhaler. Water sample tested in ml, and B is equal to volume of distilled water used in dilution. How much distilled water is mixed with water sample? Used in dilution in ml. So it is a number you will get. Okay. So our drinking water standard with respect to this. So threshold odor number should not be more than 3 as far as drinking water is concerned. So threshold odor number should be preferably less than 3. Even it is 3 also objectionable. So you can expect one numerical in example. Clear? Example. A 25 ml of, for example, a question could be asked like this. A 25 ml of water sample diluted with 175 ml of distilled water at which odor is just detectable. Find TON, threshold odor number. Then now we can work out what is given to you. Water sample is 25 ml, that is A. A is equal to 25 ml. Distilled water is how much diluted? 175 ml is diluted. Therefore, threshold odor number is equal to, it is A plus B by A. So 25 plus 175 by 25, so it is 8. Understood? That is how we can work out. Next, one more example. 12.5 ml of distilled water. 12.5 ml of water sample (12.5 ml of water sample tested in osmoscope at which odor is just detectable. Find T1. Like this also they will ask. Then in this case what happens? Only A is given, B is not given. Then how to work out? So A is equal to 12.5 ml. This A plus B, that is nothing but capacity of osmoscope. Osmoscope can accommodate only this much amount of sample. Osmoscope, which is equal to 200 ml. Okay, that's always true. Therefore, B is equal to, it is 200 minus A. So 200 minus 12.5. So 187.5 ml. Therefore, threshold odor number is equal to indirectly given B value. A plus B by A. So it is 200 by 12.5. It is 25. Sorry. It is 60. That was the answer for this question. This is how we can work out. Okay. There is no test for taste, but if odor is detected, we also presume and assume that it also tastes bad. There is no test for taste. There is no test for taste if odor is detected in water. So, detected in water, it also assumed that water tastes bad. That's all. So senses of taste and smell are so closely associated with each other. So somebody preparing gulab jam, somebody cooking gulab jam, the moment you sense the smell of the gulab jam, immediately, virtually, we started consuming the gulab jam. We feel gulab jam in our mouth, isn't it? Just by smell only, we feel that gulab jam in our mouth. So senses of smell and taste are so closely associated with each other. If water smells bad, we presume and assume that it also tastes bad. So there is no taste in water, there is no smell in water. Water thought to be odorless and tasteless. So these are the 4 water quality parameters. So what you need to remember is the drinking water standards, the devices used to measure them, and all this information you have to remember. Okay? Next. Let us move to chemical water quality. So there are so many chemical water quality parameters are there because water itself is a chemical compound which in turn hosts thousands of chemical substances, many more chemical substances, infinite number of chemical substances present in water. So practically finding each and every chemical substance present in water is not possible, practically not possible, improbable it is. Therefore, we only we only focus on only those chemical substances which are either trouble human beings by causing some health problems or trouble the property. Property also very important for us. Corrosion problem, scaling problem, this problem, that problem also property experiences because of handling with the wrong water. So therefore, any substance which affect the health of the public and as well as damage the property, they are only objectionable. Rest of the chemical substances, even they are present in water also, we ignore them. Even they are present, we don't mind them. Okay? We only try to control those chemical substances which affect the human beings by causing diseases or health problems. Not only that, some chemical substances they are absolutely safe to human beings, but sometimes they cause damage to property. Even property also important. So therefore, we try to check those chemical substances from water try to supply to the public. So here property means what? Pipe is a property, pump is a property, reservoir is a property, right? All these things are properties. Treatment units are the properties. So we have to protect this property also. So till the end of the design period, they should work. So there is no replacement of these things. So therefore, just by instead of replacing the property once it get damaged, it is better to apply small correction to water so that property also we can protect. That is a wise and better wise way of protecting our property. Instead of replacing the property, just by with minimum effort, just apply small correction to the water, automatically our property also protected. So that's what we try to do. Chemical water quality. So first parameter, first what we work out is solids we work out. Solids are nothing but residue left on evaporation. Solids are measured by gravimetry. As per the definition, it is residue left on evaporation. So solids are measured by gravimetry. Gravimetry means weight measurement. Measured by gravimetry and expressed in terms of milligram per liter or ppm. Okay? Expressed in milligram per liter or ppm. So we try to work out three types of solids. One is total solids, the other one is suspended solids, some people call it as TS, and sometimes very important solid is dissolved solids. So total solids. So to work out these total solids, what we do is we take a crucible. This is, we measure its initial weight. So we measure initial weight of empty dry crucible. Empty dry crucible. Let it be W1. We draw some known volume of water sample into this. So the volume of water sample is taken into this crucible. VML of water sample we draw into this crucible. And residue left on evaporation. We try to evaporate water. When we evaporate water, only water, H2O component disappear. Only whatever solids present in water that remain as a residue. So after evaporating the water, whatever residue left there represent what? Solids in water. Like this residue remain there. Residue left on evaporation. This is called residue. Where water has gone? Water has evaporated, escape into atmosphere. So, how water evaporate? After oven drying. After oven drying, at 103 degrees centigrade, for 4 to 5 hours, we measure final weight. So, at 103 degrees Celsius, water evaporates. Under controlled condition, we carry out this. So, final weight of crucible after oven drying. Let it be W2. Therefore, total solids in water is equal to, so it is W2 minus W1, difference in weights by V. So we can express either in terms of milligram per liter or ppm. Milligram per liter ppm, both of them are same. 1 milligram per liter is equal to 1 ppm. That's how we can work out. Okay, shall we try one numerical? So numericals only need to focus more in GATE exam. Let us try one numerical. Example. A 50 ml of water sample taken into empty dry crucible whose initial weight found to be 98.23 grams, 234 grams. Okay. Just to give you idea how to work out problems. After oven drying, its final weight measured to be 98.268 grams. Find total solids in water in milligram per liter. So like this a question may be asked. So what is W1? So only thing that you need to notice is now what is W1, what is W2, what is V. So W1 is initial weight. So the initial weight is 98.234 grams. Final weight is W2 98.268 grams. Volume of water sample taken is tested is 50 ml. Therefore, total solids is equal to, it is W2 minus W1 by V. So even if you forget also, remember you never get the solids in W2, W1 confusion is there. Highest value is taken as W2, lowest value is W1, lowest weight is W, because empty weight, empty dry crucible is lesser weight. 2, 3, 4, right? Common sense you have to use. By 50. As it is a substitute, you will get answer in, this is in grams, this is in ml. So grams per ml. To convert grams into milligrams, multiply with 1000. To convert ml into liters, multiply with 1 by 1000. Then it becomes milligram per liter. 1 liter is equal to 1000 ml, 1 ml is equal to 1 by 1000 liters. Okay? Again, no special class is required to know about units. Without units, without knowing the units, right? You don't become, we have not complete our civil engineering, isn't it? Again, special class is not required to learn about units. Civil engineers are good at units. So you have to remember that. So gram per ml, then you can convert it to milligrams. 1 gram is equal to 1000 milligrams. 1 ml is equal to 1 by 1000 liters. So multiply straight away. 10 power into 10 power 6 you multiply, we will get straight away total solids. How much it is? 340 milligram per liter. I saw somewhere people also teaching units, separate class. Engineers not required to know about units, they are experts about unit system. Okay? Second, suspended solids. Suspended solids also worked out in the same fashion, same principle, but approach is slightly different. Suspended solids. Approach is same. Approach is slightly, the method is same, but approach slightly different. Instead of taking a crucible, we take a filter paper. One filter paper we take like this. This is a filter paper. This filter paper contains what? Small pore spaces. Through that pore spaces, it allows only colloidal particle, dissolved particle. Because filter paper has got pore spaces, 4 openings. Those openings are smaller than the smallest suspended particle in water. What is the size of the smallest suspended particle? 10 power minus 3 mm. The space is the opening space. The paper contain openings having a space less than 10 point minus 3 mm. Therefore, any suspended particle present in water, if you pass that water through this filter paper, all those particles are retained on the top of the filter paper. So, we measure first initial weight of empty dry filter paper. Initial weight of empty dry filter paper. Sorry. Initial weight of empty dry filter paper is equal to W1. Then we pass some known volume of water sample through it. So water sample. So VML of water sample is filtered. So when you carry out filter is nothing but sieving, micro sieving it is. So all the suspended particles present in water, they are retained there. So particles retained in the top of the filter paper. These are the suspended particles. But okay. but paper also absorbs some water. So to remove that water, it is kept in the oven at 103 degrees centigrade for 4 to 5 hours. During that period, what happens? All water evaporates, leaving behind the solids. So therefore, after oven drying, you have to measure final weight of filter paper. Final weight of filter paper after oven drying. It is taken as W2. Again, same way. So suspended solids in water is equal to W2 minus W1 by V. Same way we can work out. Okay, this is called gravimetry. Just by measuring weights, you work out any parameter. It's called gravimetry. But we don't have any drinking water standard with respect to total solids, with respect to suspended solids. But very important water quality parameter is total dissolved solids. It is called shortcut to TDS. Total dissolved solids. This is a very important water quality parameter. We have got drinking water standard with respect to TDS. This TDS include both colloidal particles and dissolved particles. So TDS include colloidal and dissolved particles, together known as TDS. Colloidal and dissolved particles. Both of them put together known as TDS. So it is too difficult to separate colloids from dissolved particles. Therefore, both of them together we work out. It is known as total dissolved solids. Both of them are micro. They are not visible to naked eye. So to find out this, what we do is same crucible we take. So only difference is, instead of taking water sample as it is, raw water as it is, we take a filtered water. So filtered water free from suspended solids. That is give how much amount of colloidal particle and dissolved particles are present in water. So first we measure initial weight. So initial weight of empty dry crucible. Crucible is nothing but a small cup specially made for this purpose. W1. इसमें क्या लेना? वाटर लेना, फिल्टर्ड वाटर लेना भैया. इसमें फिल्टर्ड वाटर लेना. So VML of filtered water sample. This filtered water sample, technically it is known as filtrate. Okay. So then after oven drying, you have to measure final weight. So if you oven dry, residue remain there. That residue represent what? Total dissolved solids. So final weight after oven drying. After oven drying is equal to, it is W2. So therefore TDS is equal to, it is W2 minus W1 by V. We also express TDS in milligram per liter or ppm. That's all. Sometimes we also measure TDS by quickly, approximately by measuring electrical conductivity. By measuring electrical conductivity, we measure TDS quickly. TDS approximately estimated by measuring electrical conductivity of water. We call it as EC. Using conductivity meter. So there is another way of finding quickly TDS, right? Because TDS by exact method you want to measure, that only crucible method. So in that it takes 4 hours, 5 hours time because you have to evaporate water. But this doesn't require that much time. Quickly you can work out using conductivity of water, using conductivity meter. Sorry. Conductivity meter is a digital electronic device like nephelometer. It is a digital electronic device. Quickly measure TDS in water. So TDS in water is equal to this K times electrical conductivity. That's how we can work out. TDS straight away will get in milligram per liter by measuring electrical conductivity in micromos. OHM, ohm. Opposite to ohm is resistance. Resistance, electrical resistance is measured in terms of ohms. In terms of ohm we measure resistance. Conductance is measured in terms of mos. MHOs, micromos. We measure in terms of micromos. We substitute this in micromos. So straight away, K is conductivity meter constant. Conductivity meter constant. Okay. So normally its value vary anywhere between 0.5 to 0.7. He will give you, whoever manufactured that meter, that fellow will give you meter constant. You multiply that, you get TDS. Let us try one GATE problem. This question is being asked in GATE exam, GATE 2015. Before that, we have got drinking water standard with respect to TDS. I'll write that. So TDS in drinking water should not be more than 500 ppm. TDS in drinking water should be preferably less than or equal to 500 milligram per liter. More than 500, objectionable. Of course, we can tolerate so to a certain extent. More than 1000, straight away we can reject. 5 to 500,000, okay, but preferably less than 500 is good. Get to the this question. Let us solve this question. This question, tricky question. Of course, it is easy only. You are thorough with your common sense. Common sense is there, you can work out because it is. Ours is most of the times graduate aptitude test, engineering aptitude they test you. Okay, basics. So but this is best question. Aptitude, how your aptitude is tested here. Find percentage TDS in groundwater if TDS concentration in water is 500 ppm. This question is been asked in GATE exam, GATE 2015. Any sound problem is there? Is it echoing? Echo is coming to you? On by a comment. Okay then. Find percentage TDS in groundwater if TDS concentration in water is 500 ppm. Come on, how to work it out? So you suppose know what is ppm. So solution. ppm means parts per million. X ppm of any substance in water means X part of that substance present in X part of that substance, X parts of that substance, right, in 10 power 6 parts of water. That's the meaning. So 500 ppm of TDS means what? 500 ppm of TDS means 500 parts of TDS in 10 power 6 parts of water. So therefore percentage TDS in water is equal to, it is 500 by 10 power 6 into 100. 500 by 10 power 6 into 100 is 0.05%. 10 power 6, no, this is 2 to cancel. So it is 5 by still 4 gone, still 2 is there, 5 by 100. 5 by 100. Yes, 5 by 100 is 0.05%. Yes, this is the answer for that question. One mark question in GATE 2015. Okay. That's how we need to answer. Next important parameter is pH. Of course, very important parameter for GATE exam point of view. So numericals you can expect from this. pH stands for what? Potential of hydrogen ion concentration. Measure of potential of hydrogen ion concentration. Whenever substances dissolve in water, either they dissolve in positively charged hydrogen ions or negatively charged hydroxyl ions. Positively charged H plus ions or negatively charged OH minus ions. We see water itself. If you split this water component, you find H plus or OH minus. Positively charged H plus ions or negatively charged OH minus ions. This H plus ion is called hydrogen ion concentration. OH minus is hydroxyl ion. Hydroxyl ion. Okay. So pH is the measure of H plus ions. So if H plus ions are known, you can find out pH. If pH is known, you can find out H plus ions. That type of questions mostly they are asking in GATE exam. They'll give you OH minus ion. There is a relation between H plus ion. So the relation between H plus and OH we can establish by writing ionization equation. So relation between H plus and OH minus. This relation we can work out by writing ionization equation. What is ionization equation? Product of products by product of reactants is equal to K. Product of products by product of reactants is equal to ionization constant K. Okay, we got product of products. This side is reactant, this side is products. So H2O if you split, you can get H plus and OH minus. So H plus into OH minus, we can write like this. So by writing ionization equation for the above reaction, I will take this is 1, chemical reaction 1. By writing ionization equation for equation 1, we can work out. What is ionization equation? Product of products by product of reactants, H plus into OH minus by H2O is equal to K. This K is called ionization constant, whose value depends on temperature. So for water, for pure water, right, at a temperature 25 degrees Celsius, K value is taken as 10 power minus 14 and H2O value is taken as 1. So if you substitute those values, H plus into OH minus by H2O is 1 is equal to 10 power minus 14. Therefore normally H plus, the product of H plus into OH minus is always constant, whose value is always taken as 10 power minus 14. H plus into OH minus is always constant, whose value is equal to 10 power minus 14. Units of this ionic concentrations are measured in terms of moles per liter. This is one useful expression which you are supposed to know. Then this equation further you can simplify by applying log on either side. From there we got expression for pH and pOH. By applying log on either side, so log 10 on either side, log 10 H plus plus log 10 OH minus is equal to log 10 10 power minus 14. Okay? Log 10 10 power minus 14 is how much it is? Minus 14 only. I'll write straight away minus 14 here. Log 10 10 power minus 14 is minus 14. Actually it is log 10 10 power minus 14, which is nothing but minus 14. I want to remove this minus term from there. So to remove minus term from there, okay, I want to make it positive. What I need to do? This side of the equation I will readjust. Log 10 1 by h plus I can also write like this. Log 10 1 by OH minus is also equal to 14. This way also I can write. So writing this always is difficult. This log 10 1 by h plus is replaced by pH. Log 10 1 by OH minus is replaced by pH. Potential of hydrogen and potential of hydroxyl ions. Therefore, what is pH? pH is nothing but log 10 1 by h plus negative logarithm of hydrogen ion concentration. Or you can write like this, minus log 10 negative logarithm of H plus ion concentration. What is pOH? So log 10 1 by OH minus ion concentration. So it is minus log 10 OH minus. This way also you can write. That is how this concept came. Understood? Hope it is clear to you. Then they ask questions. pOH will be given, you are expected to pH, and pH is given, you are expected to find out pOH. So, log 10 1 by H plus, log 10 1 by OH minus. When you replace both of them by this, then what happens? You get one more useful expression, pH plus pOH is equal to 14. So that's how it came. pH scale came into picture. We replace that values. So, if you know pOH, you can find out pH. If you know pH, you can find out pOH. So when pH value or pOH value normally range from 0 to 14. Maximum is 14, minimum is 0. pH scale or pOH scale, whatever you call. Exactly at center it is 7. This is called pH scale. If pOH is 0, pH is 14. If pOH is 14, pH is 0. Like that. This is called pH scale. So close to 0 pH, water is treated as acidic. Close to 14 pH, water is treated as basic. And close to 7, it is treated as neutral. So that is how we can find quickly the nature of the water. Why pH is very important water quality parameter? The reason being, water treatment is pH dependent, and one particular pH, the best treatment happens. At some other pH in same water, no treatment happens. When pH changes, it affects the degree of treatment. Okay? And second important thing is, quickly we can find out nature of the water. Whether water is acidic or basic. That we can find out. Third important thing is, why pH is measured is, I told you, the water treatment is pH sensitive. Second is, quickly we can find out whether water is acidic or basic with the help of pH. The third important thing is, why pH need to be measured is, cost of chemicals used in water treatment, that also depends on pH. At one particular pH, while treating that water, it requires very less amount of chemicals to treat water. At some other pH, treating water, it requires huge amount of water. So cost of treatment also depends on pH. So, and moreover, over and above, extreme pH water damage the property. Extreme pH means close to 0, close to 14 is not a damage the property. Therefore, we try to maintain neutral pH, close to neutral. That is always better to protect property. Drinking point of view, absolutely safe. There is no problem at all with respect to pH. But property point of view, it is objectionable. That's why pH need to be measured. But one numerical you can expect in GATE exam, ESE exam related to pH. And anyway, calculator is allowed in GATE exam, comfortably you can manage. Question could be like this. GATE question, I am saying. If a OH minus ion concentration in water is 10 power minus 8.6 or 10 power minus 4.6 moles per liter, then find pH of water. Question could be like this. He has not given pH, but you are expected to find out pH. But what is given indirectly? OH minus ion concentration is given. Come on, tell me how to work out. Right? What is given to you? OH minus ion concentration. 10 power minus 4.6 moles per liter. Okay? Then you have been asked to find out what? pH. So, we have got one equation. H plus into OH minus always equal to 10 power minus 14 moles per liter. From this can't work out H plus ion concentration. H plus ion concentration is equal to 10 power minus 14 by OH minus ion concentration. 10 power minus 14 by 10 power minus 4.6. So how much it is? 10, what is left there? Plus 4.6, so 14 minus 14 plus 4.6, 9.4. 10 power minus 9.4 moles per liter. H plus ions are known, can't work out pH. Therefore pH is equal to, so it is log 10 1 by H plus ion concentration. So log 10 1 by 10 power minus 9.4. So log 10 10 power minus 9.4, it is 9.4. That's how we can work out. Or otherwise, you know pH plus pOH is equal to 14. So OH minus ion concentration is known to you. This is method 2. Ten power minus 4.6, right? Moles per liter. Therefore, pOH is equal to log 10 1 by OH minus ion concentration. Log 10 1 by 10 power minus 4.6. Log 10 10 power minus 4.6 4.6. So since pH plus pOH is equal to 14, therefore pH is equal to 14 minus pOH. So 14 minus 4.6, which is equal to 9.4. That way also you can do it. Either this way or that way. Whichever way you feel comfortable, you can solve the problem using that procedure. Clear now? So let us take few more examples related to this pH. Let us take some GATE questions related to pH. This question has been asked in GATE 2012. Good question it is. Similar kind of question only, but slightly different. A water sample has pH of 9.25, the concentration of hydroxyl ions in the water sample is, options given to you are A, 2 marks question in GATE exam, this is 2012, 10 power minus 9.25 moles per liter. Option B is given as 10 power minus 4.75 moles per liter. Option C is given as 0.302 milligram per liter. Option D is given as, this is millimoles per liter. Option D is given as 3.020 milligram per liter. This is millimoles per liter. Like this he has given. So only one option is right. Which option is right? Come on, find out. Come on, find out, guys. Which is right? Come on, guys. Similar lines to last problem. pH is given. You have been asked to find out OH minus and concentration. How to proceed? So OH minus and concentration have to find out. So pH is given as 9.25. So since pH plus pOH is equal to what? 14. Therefore, from this you can write pOH is equal to 14 minus pH, 14 minus 9.25, which is equal to 4.75, right? pOH is equal to 4.75. If pOH is equal to 4.75, what is pOH? Log 10 1 by OH minus. This is 4.75 log 10 1 by OH minus. And if we simplify, what we will get? OH minus and concentration is equal to 10 power minus 4.75 moles per liter. That was correct answer only. But unfortunately, here 10 minus 4.75 is there, but unit is not matching. So this is not correct answer. Millimoles per liter is given. M moles means millimoles. Moles per liter answer 10 power 9.25. This number also not matching, therefore this is also wrong. This is also wrong, this is also wrong. If we work out in millimoles per liter, how to convert moles into millimoles? Let us verify. M moles per liter means this is millimoles per liter. Means 10 power minus 3 moles per liter. Milli means 10 power minus 3. If you convert this OH minus in, right, moles per liter into millimoles per liter, moles per liter to millimoles you want to convert 1 by 1000. 1 by 1000 if you subtract 1 by 10 power minus 3. So 10 power minus 3 if you, so 10 power 4 minus 4.75 plus 3. So it becomes 10 power 1.75 moles per liter. Isn't it? Milli means 10 power minus 3. So it is negative value decreases. That means moles to milli. Milli means very small value. So this is also okay. But this is moles per liter. Millimoles per liter. You want to express in terms of millimoles per liter, it should be 10 power minus 1.75 millimoles per liter. Because how to convert moles per liter into millimoles per liter? 1 mole per liter is equal to 1 by 10 power minus 3 millimoles per liter. So if we divide by 10 power minus 3, this become 10 power minus 1.5. So this is also not matching. That's why I ruled out. So I again have to verify with milligram per liter. So to convert millimoles per liter to milligram per liter or moles per liter to milligram per liter. So the ionic concentration normally expressed in moles per liter. But we have to convert that into mass concentration. So how to convert milligram per liter to mole per liter? So milligram per liter of any substance is equal to moles per liter of that substance into molecular weight of that substance into 1000. Do this. Moles per liter, molecular weight. Molecular weight has got units gram per moles. So to convert this gram per moles, right? Molecular weight has got unit gram per moles. So moles get cancelled. Then we left with gram per liter. To convert grams into milligrams, we multiply 1000. That's how we can convert. So we have got answer. Okay. How to convert to vice versa also. So how to convert this into milligram per liter? We got it. Okay. So we got 10 power minus 4.75 moles per liter. So OH minus ion concentration 10 power minus 4.75 moles per liter. This we have to convert into milligram per liter. So what to do? 10 power minus 4.75 into molecular weight of OH minus into 1000. Then it becomes milligram per liter. Understood? So if we simplify, 10 power minus 4.75. What is molecular weight of OH? O is 16, H is 1 into 1000. So it is 0.302. If we simplify, you get 0.302 milligram per liter. This is the answer for that question. 2 marks question in GATE exam. Many students that time they did not pick up this answer properly because they attempted 4.75 is number is there, they are tick mark on that one, but that unit is millimoles. If it is moles per liter, this is also right, but unit is millimoles. Moles per liter answer, number is not matching, unit is matching. Here number matching, but unit is not matching. Here unit matching, number not matching. So both unit and number matching for C. Therefore C is the correct option. This is also wrong. That's how we get it. Work out. So nowadays MSQ questions, so multiple selective questions will be there. So we give answer in 2 units. Moles per liter also will give, millimoles per liter also will give, and milligram per liter also will give. So that's how it will confuse you. You should be careful. So unit conversion. Of course, chemistry related unit conversion is tough to civil engineer. The rest of the things we are perfect only, isn't it? Hope you got it. Okay. Let us try one more question. The concentration of OH minus ions in water sample measured as 17 milligram per liter at 25 degrees Celsius. What is the pH of water sample? Come on, work out. So only conversion, that's all. Solution for this question. OH minus ions concentration is given in milligram per liter. Okay. So this you have to convert into moles per liter. OH minus ions in moles per liter is equal to OH minus ions in milligram per liter by this equation, reverse it. Molecular weight of OH into 1000. So molecular weight of OH minus into 1000. Come on, it is 17 by 16 plus 1, 17 molecular weight into 1000. So it is 10 power 17 get cancelled, 10 power minus 3 moles per liter. OH minus ions. OH minus ions are known to you. The next step will get answer. Therefore, POH is equal to, so log 10 1 by OH minus ions. So it is log 10 1 by 10 power minus 3. So it is 3 POH. Therefore pH plus POH is equal to 14. Therefore pH is equal to 14 minus POH. So 14 minus 3 it is 11. That was the answer for that question. So this is how you will twist you. I hope the concept is clear to you. How to convert ionic concentration from moles per liter to milligram per liter, milligram per liter to moles per liter. I'll teach you one more concept to you. Conversion. Similarly, so I'll write here. Concentration of X. X could be any chemical substance. We are converting concentration of X in different unit systems. X could be any chemical compound. This ionic concentration of the substance. So, ionic concentration of X measured either in terms of moles per liter or equivalence per liter or milli equivalence per liter. So normally in our we work out in milligram per liter. Then you want to add subtract any ionic substances, they should be in moles per liter or equivalent per liter or milli equivalence per liter. So how to convert this? So just now we discussed how to convert moles per liter to milligram per liter, milligram per liter to moles per liter. So if concentrations are given, if ionic concentrations are given in milligram per liter, they have converted into moles per liter before we carry out mathematical calculations. So that's point you have to remember. So concentration of X in milligram per liter is equal to concentration of X in moles per liter into molecular weight of X into 1000. Then this becomes moles per liter is converted into milligram per liter. Similarly, concentration of X in moles per liter is equal to, if it is given in milligram per liter. So concentration of X given in milligram per liter by molecular weight of X into 1000. Okay? This is how we can work out. Similarly, equivalent weight. Concentration of X in milligram per liter you want to work out. So concentration of X given in equivalence per liter into equivalent weight of X. Equivalent weight of X got units a gram per equivalence. Therefore they cancel out. Multiply with 1000. So therefore concentration of X in equivalence per liter is equal to, understood no? Concentration of X measured given in milligram per liter by equivalent weight of X into 1000. Practice this. 1 or 2 questions solved, you will be comfortable. Conversions. Similarly, milli equivalence per liter, that is very popular. Concentration of X in milligram per liter want to work out. If concentration of X is given in milli equivalence per liter, just multiply with the equivalent weight of X. or concentration of X, you want to find out in milliequivalents per liter. Then what you need to do? Concentration of X given in milligram per liter by equivalent weight of X. That's all. This much idea is there. You will, chemistry is cakewalk to you. Chemistry related numerical questions become so simple and so easy to you if you are familiar with these conversions. Understood? Ionic substances, they are not added, subtracted, divided, multiplied when their concentrations are in milligram per liter. So they should be converted into ionic concentration, either in moles per liter or millimoles per liter or milligram per liter or milliequivalents per liter. So equivalent weight is equal to what? What is equivalent weight? Equivalent weight is equal to, it is molecular weight by valency. From there you can find out equivalent weight. Okay? Valence is nothing but a charge. How much charge that particular substance carry with it. Understood? Okay. Now using this, anything you can work out. Now let us solve one more question related to pH, numerical. Okay. This question has been asked in all competitive exams, including GATE, IES, state government exams, all exams they have asked. How many times? Two samples. Okay, sorry. I read question completely. Two samples of water A and B. Have pH values of 4.4 and 6.4 respectively. How many times more acidic sample A than sample B? How many times more acidic sample A than sample B? So whichever is close to 0, that is more acidic. Just now we discussed. pH value changes from 0 to 14. 0 to 14. So whichever is close to 0, that is more acidic. So between them, sample A is 4.4, sample B, this is 4.4, sample B is 6.4. This is A, this is B. So which is close to this 7, let us assume. Which is close to 0. So sample A. Obviously sample A is more acidic than sample B. But how many times he is asking? Okay. So let us see. So work out ratio. So sample A by sample B. But sample A by sample B means what? pH of A by pH of B. But pH you cannot involve straight away because there is a logarithmic term in that. So we can't involve. This is wrong. If you write pH A by pH by B, 4.4 by 6.4 you will get. So this is wrong. Wrong way of doing the things. So we should not involve pH straight away in calculation. You have to remove that logarithmic term you have to involve. So instead of taking pH of A, we take H plus of A. H plus of A of sample, H plus ions of sample B. Work out, this is right way of working out the things. This is right. pH never ever be involved straight away in calculation because of logarithmic term. So what is H plus of A ions? pH is given as pH of A ions is how much? 4.4 pH. pH of A is 4.4. From this H plus of A is how much? Straight away 10 power minus 4.4 moles per liter. pH of B is how much? 6.4. What is H plus of B? 10 power minus 6.4 moles per liter. So if you involve straight away H plus ions, then you get how many times it is more. Always H plus ions only taken into account, not the pH. Because pH is accompanied by logarithmic term. Logarithmic scale is different, normal scale is different. Logarithmic scale, normal scale start like this. 0, 1, 2, 3. Logarithmic scale start how? 10 power 0, 10 power 1, 10 power 2, 10 power 3. This is logarithmic scale. Log 10 scale. This is normal scale. So difference on normal scale is 2 means difference is 2 only. Normal scale, this scale if you see. It's not 2. So 2 difference on normal scale is many times difference in logarithmic scale. Understood? Therefore, this is not used, this is right. This is in logarithmic scale, this value. So that should be converted into linear scale like this. Converted into linear scale. Then you can compare how many times it is more and more. Logarithmic scale. This value is in terms of logarithmic scale. This all is in terms of linear scale. Normal scale. Linear scale means normal scale. This is log scale. Okay? So if I involve H plus of A by H plus of B, ratio if you work out, it is 10 power minus 4 by 4.4 by 10 power minus 6.4. You simplify, it is 100. Therefore, sample A is 100 times more acidic than sample B. That is how we can conclude. This question so many number of times in every exam they ask. All state government exams they ask this question. ESE exam they ask this question, right? Then GATE exam also they ask this question. One more, let us try. There are when 2 or more number of water samples having different pH values, if you mix, what is the concentration of the mix? Concentration of the mixed solution we can find out by mix formula. Understood? If we take a container, right? This is a container with opening. We are adding so many number of solutions with different volumes. So, solution A, right? VA, volume is VA. Solution A, how much volume added? VA volume. Concentration of that is CA, let us assume. Solution A, water sample A, water sample B, water sample B, all of them we are adding here. solution B, chemical solutions, whatever it may be, solution C, etc. Any number of things, any number of solutions you can add. Right? Its volumes are VA, VB, VC, VN, and concentrations are CA, CB, CC, CN. Let us assume these are the volumes, these are the concentrations. They are all added into this container, the samples. And after mixing all these substances, all these solutions here, after thorough mixing, what is the concentration of the mix? Now total volume here is equal to how much here? VA plus, VB plus, VC plus, dot 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 VN. But its concentration how much it is C mix. So that what we collect here is concentration C mix. How to work out the C mix value? So using a mix formula you can find out. Mass in is equal to mass out. By using mass balance equation work out. Mass in is equal to mass out. So we write mass in is equal to what? What is mass in? So VA into CA plus VB into CB and so on to mass balance equation, writing around this. So mass in is equal to mass in into container is equal to what? VA into CA plus VB into CB plus so on to VN into CN. Mass out from container is equal to how much it is? Mass out from container is equal to, it is VA plus VB plus VC plus dot 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 VN in number of solutions whose concentration is C mix. That is mass out. So mass in is equal to mass out. If you equate, you will get equation to find out concentration after mixing them. Mass neither be changes, mass neither created nor destroyed. Mass balance equation it is around the container. Mass in must be equal to mass out. Therefore mass in is equal to what? VA into CA plus VB into CB dot 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 VC into CN is equal to mass out is equal to VA plus VB plus VC plus dot 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 VN into C mix. Therefore C mix is equal to what? Generalized expression. VA into CA plus VB into CB. Let it contain any number of solutions, no issue. VN into n number of solutions by VA plus VB plus dot 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 VN. This is a mixed formula. It could be volume or it could be flow rate also. Sometimes discharge also you can take. Volume by time is equal to discharge. So flow rate is nothing but volume rate only. Rate of volume is nothing but discharge. So sometimes we can also write this equation in terms of discharge. So C mix is equal to, so two or more number of rivers, streams, drains joining at one point, then concentration of substance in that also can find out. Like QA into CA or QB into CB. Like this, any number of solutions you can add, their concentrations you can work out by using these equations. Understood? So this water quality topic only they are asking many questions. Wherever numericals scope is there for numericals, from there you will get a guarantee question in exam. Okay? Let us try one question. GATE kind of exam. This question has been asked in GATE exam. Of course, it is a GATE question only. Find out the pH of mixture found by mixing the following two solutions. Formed by mixing the following two solutions. Two solutions are they are mixing. solution A, VA 300 ml and whose pH is equal to 7. Solution B, volume is 500 ml, 700 ml. Its pH is 5. Come on, work out now. Try. At least. Try बाबा, try. कोशिश करो. करने के लिए कोशिश करो. That's all. Okay. So what to do? We should not involve pH in calculation part. Instead, we should involve H plus ion concentration. So therefore, pH of solution 1, solution A is, first solution pH is 7, second solution pH is 5. So H plus of solution A is 10 power minus 7 moles per liter. H plus of solution B is 10 power minus 5 moles per liter. Okay? Now H plus of mix is equal to, so VA into H plus of A plus VB into H plus of B by VA plus VB. So VA is how much? With volume 300 ml. 300 into 10 power minus 7 plus 700 into 10 power minus 5 by 300 plus 700. Come on, work out this value. So 300 into 10 power minus 7 plus 700 into 10 power minus 5 by 1000. So it is 7.03 into 1, 2, 3, 4, 5. 10 power minus 6 moles per liter. Therefore, pH of mix is equal to pH of mixed solution. After mixing, what is its pH value? So it is log 10 1 by H plus of mix. That's all. So log 10 1 by 7.03 into 10 power minus 6. I got 5.15. So calculation took me little time. So this is how we have to work out. Hope it is clear to you. So that's how we can work out pH problems. And we also have got drinking water standard with respect to pH. So it should not be too high. It should not be too low. pH of drinking water should lie anywhere between 6.5 to 8. Or some people take 8.5 also. It's okay. That also you have to remember. This question is over here. Answer for that question is this one. Understood? That's how we can work out numericals related to pH. Next important parameter is alkalinity. GATE exam point of view. Next important chemical water quality parameter is alkalinity. Of course, acidity also there, but not required for GATE exam. Alkalinity is important. Alkalinity to water is normally caused by hydroxyl ions, carbonate ions and bicarbonate ions. Hydroxyl ions, OH minus, carbonates, CO3 double minus and bicarbonate ions. Bicarbonate are called HCO3 minus. So carbonates, bicarbonates and OH hydroxyl ions, they cause alkalinity. Normally, OH minus ions contribute significant amount of alkalinity to water when pH of water is greater than 10.2. So carbonates cause significant amounts of alkalinity when pH of water is between 8.3 to 10.2. And bicarbonates contribute significant amount of alkalinity to water when pH of water is between 4.2 to 8.3. So in this range, both carbonates and bicarbonates contribute alkalinity. In this range, only pH contribute. So when OH minus contributing alkalinity caused by carbonates and bicarbonates is negligible. When carbonates and bicarbonates contributing alkalinity caused by OH minus is negligible. So all three together do not contribute significant amount of alkalinity. These two may contribute, but all three not together. So alkalinity, total alkalinity of water we measure by measuring the concentration of OH minus, by measuring the concentration of carbonates, by measuring the concentration of bicarbonates. Therefore, total alkalinity in water estimated by measuring concentration of OH minus ions, carbonate ions and bicarbonate ions in water. Okay? And total alkalinity is expressed in terms of milligram per liter as CaCO3. This is very important. So therefore, there is one numerical equation to work out total alkalinity. So remember all of you. So total alkalinity in milligram per liter as CaCO3 is equal to this First OH minus ion concentration. Normally it is given in milligram per liter, so this has to be converted into milliequivalents per liter. Again you have to convert it to milligram per liter as CaCO. Therefore it is multiplied with the equivalent weight of CaCO3 by equivalent weight of CaCO3 by equivalent weight of OH minus ions plus carbonate ions concentration into in milligram per liter into equivalent weight of CaCO3 by equivalent weight of carbonates plus bicarbonate ion concentration into equivalent weight of CaCO3 by equivalent weight of bicarbonates. So what is equivalent weight? Molecular weight by valency. Equivalent weight of CaCO3 by is equal to molecular weight of CaCO3 by valency. What is molecular weight of CaCO3? Ca plus C plus 3 into O. Valency is 2. Ca 2 plus, it has got maximum charge is 2, therefore valency is taken as 2. So Ca, molecular weight 40 plus 12, 3 into 16 by 2, so it is 50. Similarly, equivalent weight of OH minus ions is equal to molecular weight of OH minus ions by valency. Molecular weight is 16 plus 1, valency is 1, OH minus 1 charge, therefore 1, so 17. Similarly, equivalent weight of carbonates. So molecular equivalent weight, equivalent weight of carbonates. Molecular weight of carbonates by valency. Double minus no? Double minus means valence is 2. C 12 plus 3 into 16 by 2. So it is 30. Equivalent weight of bicarbonates. So molecular weight of bicarbonates by valency. What is molecular weight of bicarbonates? H is 1, C is 12, O3, 3 into 16 by 2. It is 61. Oh, sorry, 1. Charge is only 1. HCO3 minus, no, only 1 minus. Only 1 charge. Valence is 1. So therefore, finally, total alkalinity in milligram per liter as CaCO3 reduces to simple form. If OH minus ions given in milligram per liter, this is to be multiplied by 50 by 17. Carbonates also given in milligram per liter. This is to be multiplied with 50 by 30. Bicarbonates also given in milligram per liter. This is to be multiplied with 50 by 61. That's how we can get. Or otherwise, if total alkalinity, they are given in ionic concentration, given in moles per liter or something like that, or equivalents per liter, or milliequivalents per liter. Normally they will give in milliequivalents per liter. Milliequivalents per liter. Then you need not multiply with 50. Just multiply with 50. Carbonates, most of the times, to confuse you, you give in milliequivalents per liter. It is so simple and so easy to convert milliequivalents per liter to milligram per liter. That 1000 business is not there. So this is how we can work out. If they are given in milliequivalents per liter, this is the equation. If they are given in milligram per liter, use this equation. These two are thorough, then you can comfortably solve numericals related to alkalinity. If OH minus is not given, if any of the things, then you can take it as 0. Carbonates are not given, you can take it as 0. Bicarbonates are not given, you can take it as 0, like that. If they are present, they will give you. If they are not present, they will not give you. And by default, you can understand that they are not there in water, something like that. Hope it's clear to you, let us solve few numericals related to finding total alkalinity. Example, the water sample carbonate ions is equal to 90 milligram per liter, bicarbonate ions is equal to 61 milligram per liter. What is alkalinity of water?
Nothing but total alkalinity only.
So total alkalinity is equal to OH minus into 50 by 17 carbonates into 50 by 30 whenever they are given in milligram per liter, 50 by 61. Whenever concentrations are given in milligram per liter, we use this. Our concentrations are given in milliequivalents per liter, straight away one more equation is given to you. So since OH minus is not given, OH minus ions are not given. So they are taken as 0. Therefore, OH minus ions taken as 0. Therefore, total alkalinity is equal to 0 plus carbonates 90 into 50 by 30, bicarbonates 61 into 50 by 61. ESE question this is. So 150 plus 50, 200. So this is 200 milligram per liter as CaCO3. That was the answer for this question. Hope this solution is clear to you. Okay, let us take one more example. I think this is a GATE question. Let us take one GATE question. This question has been asked in GATE 2009. Following chemical species were reported for water sample. Find total alkalinity. He has given so many, but whatever we require, that only we take. Following chemical species were reported for water sample from a well.
He has given chlorides.
Chlorides is equal to 15 milliequivalents per liter. Concentrations are given in milliequivalents per liter. Sulfates are given. Sulfates 2 minus it is 15 milliequivalents per liter. All his concentrations are given. Carbonates CO3 double minus or 2 minus also they can write. They can also write 2 minus. This is given as 0.5 milliequivalents per liter. Bicarbonates 30 milliequivalents per liter. all these are given, but we take only, many things are not required for us. Calcium, Ca2 plus. This is given as 12 milliequivalents per liter. Magnesium, Mg2 plus, is given as 18 milliequivalents per liter. We take only whatever we require, and pH also given, not required. This is 8.5. Okay. So what are the substances required to be taken for calculation part? For us, carbonates, bicarbonates, OH. So carbonates are there, bicarbonates are there. With this we can find out. Since OH is not given, we assume as 0. Since OH is not given, so it is taken as 0. Therefore, OH minus ions we take it as 0. Total alkalinity is equal to, and we have been asked to find out total alkalinity. Find alkalinity present in water. In milligram per liter as, rest of the things you can ignore. Only whatever we require, that only we take. Remaining things you can ignore. So OH minus milliequivalents per liter no given into 50, carbonates into 50 plus bicarbonates into 50. Because concentrations are given in milliequivalents per liter. I gave. So most of the times they will express in milliequivalents per liter. So in milliequivalents per liter, it's so simple. So 0 plus, carbonates are given as 5 into 50, and bicarbonates are given as 30 into 50. So it is 1750 milligram per liter as CaCO3. That is alkalinity in water, total alkalinity in water. So this is how we work out the questions. Questions related to alkalinity we work out like this. Let us solve one more question. Okay. Alkalinity question is very popular in GATE exam. Okay, I'm not finding the question. Anyway, so very rare we come across with only one substance contributing R. So one question is there, I remember. Okay, 1 minute I'll take this question. Right, this question, let us try. This also asked in GATE exam. The pH value of water sample is 9. pH value of water sample is 9. Then alkalinity caused by OH minus ions in milligram per liter as CaCO3. Only alkalinity cause by OH. Since CO3 and CO3 not given, we take it as 0. But OH minus ions also not given straight away, indirectly given solution. So pH is given as 9, therefore pOH is equal to 14 minus pH. So 14 minus 9, it is 5. Therefore OH minus ion concentration is 10 power minus 5 moles per liter. But I will convert this into milligram per liter. So OH minus ions in milligram per liter is equal to 10 power minus 5 moles per liter into molecular weight of OH minus 16 plus 1 into 1000 milligram per liter. So 17,000. So it is 0.17 milligram per liter. Therefore, total alkalinity caused by OH is OH minus ions into 50 by 17, carbonates into 50 by 30, plus bicarbonates into 50 by 61. If they are given in milligram per liter concentration. Since carbonates and bicarbonates are not given, they are taken as 0. So 0.17 into 50 by 17 plus 0 plus 0. Since carbonates and bicarbonates are not given, therefore carbonates is equal to 0, bicarbonates also taken as 0. Okay? So 17 by 0.17. 0.17 into 50 by 17. How much it is? 0.17 into 50 by 17. It is 0.5 milligram per liter as CaCO3. That is how we can work out. Understood now? Alkalinity. So indirectly also they can ask you. So mostly all three do not contribute together. When OH contributing, CO3 and HCO3 they do not contribute. When CO3 HCO3 contributing, OH normally contribute little, but it is ignored, insignificant. Therefore, most of the times we ignore. That is how we can work out questions. Okay. Tomorrow we will discuss about hardness. So before we close, let us see this promotional content. Get an exam like experience for GATE and ESE mock exam. Enroll for free. Use code GATE Civil. Okay, GATE Civil. Use code GATE Civil. Mock exam. Then Unacademy subscriptions. This is something related to marking exams, test series. You can avail this also, 10% off. Then GATE 2023. This is also iconic subscription. You can subscribe. Okay, if you wish, you can make use of advantage. Features of Unacademy subscriptions. Top educator digital notes test series will be there. Plus subscription, iconic subscription per month. Even EMIs are also available. You can make use of this. See its code GATE Civil. Okay. Go through this once again.
And thank you very much. Again, we'll meet tomorrow
same time, same place. If you have any doubt, you can ask me. So I am ready till 3-4 minutes time is there. You can see the doubt session also. You can clarify your doubts. Any doubts are there? You can clarify your doubts. So no one is asking me doubts, okay? You can type there. Okay then,
We'll meet again tomorrow.
same time, same place. Until then, goodbye and bye bye. Shiva Ratri for all of you.